we're going to connect two identically sized tanks together. And there's actually two different ways of doing this. If these tanks are going to truly be identical, we can actually replicate them right within SuperDerive. Or if we think that we might actually want to change them and have different parameters controlling them, we could create separate copies in here where we have this child. We could take this and duplicate it and then make any changes that we want to it and have a second copy there. Given that I think we're going to have these two tanks be different eventually, I propose that we make a second copy here. So we're just going to copy this tank one, and we're going to drop another one in. We're going to call this tank 2. And so now we have a second tank. We're going to go here and let's see, we have this one tank placed on the origin, and we want to place a second tank, and this second tank, we would like it to be 10 meters away, and we also need to have some elevation difference so that water will actually flow from the one tank to the other. So let's make the second tank be a whole 4 meters lower than the first tank. And so the way we can do this is we can bring in SuperDerive, and we'll use this to bring in the second tank. So we're going to go select a part studio. We're going to select other documents, things that I recently played with. This is in the parts service is where the tank is located. So I've got that tank. And for our location, we're going to locate it also on, let's see, let's hide all these parts. I'm going to also locate it relative to the origin. There's many ways of doing this. We're going to locate it relative to the origin, and we're going to use this mate connector to move it. So this mate connector that I've created, I'm going to go and edit that mate connector, and I'd like to move this guy 10 meters, which I shouldn't be using a constant. So I'm realizing I've got some more work to do. I don't want to actually use a constant here. I want to come in and actually use a parameter. So this is controlled. So I'll just enter that for now, and we'll come back and we'll fix that. But we see that we indeed move this tank 10 meters away from where it was originally. And then we're going to custom configuration and use overrides, and we're going to refer this to tank 2, which doesn't exist yet. Let's go find out why tank 2 doesn't exist. I think I forgot to hit commit. And so that made tank 2 not exist. And the other thing that we recognized is that we needed a distance between the tanks, and we want that tank S, so S standing for the space between the tanks, we want that to be equal to, goodness, this could be as little as 0 meters apart, and we're going to try to get them 10 meters apart, and you could have them as far apart as you want. And also we have a difference in elevation, so let's call that a delta H. And we're going to let that be, it could be anywhere from 0, but we're going to want to make that 4 meters. Okay, so now I have a few more inputs, and I can go back here and in this configuration JSON where I'm going to patch in the parameter that's going to actually be used to control this. Now tank 2 is available. So tank 2 is now controlling this. And in the mate connector, I want to move it I want to move it tank S. And in the Z direction, I want to move it a negative delta H. So that looks good. And let's bring our original tank back so we can see both of them. So there they are. They're a little distance apart. They've got a vertical offset of our distance that we've specified, delta H, of 4 meters. But let's check out the space between these tanks. Okay, so we're checking between here and here. And the parallel distance is 4.8 meters. It's not 10 meters. And the reason is that the first plant is set relative to the origin, and the second plant is offset by a distance 10 meters from that origin. So indeed, if we check between this line and that surface, that parallel distance is 9.75, aha. And so if we check between that first line and this line, identical parts on the tank, those are offset by exactly 10 meters. But what we'd like is the distance between the tanks to be 10 meters. And this raises a question, like, is there any parameter that would give us like the overall length or width of a tank? Is there any parameter like that that's already calculated for us? Well, we have these maps over here that show us what the tanks know about themselves, but we can't see the whole map very easily. And so in order to display that map, we have a little print tool that we can use. It's called Print Design Output. And when we print the design output, it prints it, and oh, what a mess it is. So let's look at, we can home in a little bit at least, and let's home in on the tank 1. And when we home in on tank 1, so here's the requested submap tank 1, and there is an inner width and there is an OL, and OL stands for outside, or the outer length, and outer width. So there's the number that we want, because we would like to move the tank by an additional outer width. So let's go and see if we can make that change. Let's go into SuperDerive and into that mate connector, and where we moved it 10 meters, tank S, let's add to that tank 1 dot, we're going deep into that map, OW, and I'm going to hit a space after that so that it doesn't try to do any autocompletes. And let's go see if we've succeeded. So now I'm going to measure between this space and this space, and we've got exactly 10 meters. So we've succeeded in offsetting by 10 meters, and we did that by discovering that indeed there was we needed to move it by the outer dimension of the tank, and that dimension was already calculated by the SMART subcomponent. Okay, we'll suppress this unless we need it in the future, just so it doesn't take up processor time calculating that value.